Okay, picking up with the next example, same function, this time as x approaches 1.5 from the left in green. So close to 1.5, but on the left. Now I'm going to go to the function, and what I get here is this arrow up here. So on the left, let's make that a little more legible. On the left of x equal 1.5, graph goes nearly straight up. And so we're going to describe that as saying that the limit as x approaches 5 from the left is infinity. On the right, in pink, similar right here, and then I kind of go down to see what the graph's doing. On the left, right, of x equal 1.5, graph goes nearly straight down. And so we say that the limit will be negative infinity. And again, one of the things we're trying to get at here is the relationship between graphs and limits and graph. If you know the graph, you can find the limits. If you know the limits, you can predict what the graph is going to do. That this limit right here, the limit as x approaches 1.5 from the left being infinity, would have told me on the left the graph is going nearly straight up. Knowing this one, that as we approach x 1.5 from the right, that it's negative infinity, would tell me that I know that the graph has to be going nearly straight down. That at 1.5, the two-sided limit, we can't say anything other than it does not exist. And that is because left did not equal right. Now, had both of them been infinity, we could say that the two-sided limit was infinity. If both left and right had been negative infinity, we could say that it was negative infinity. But here, all we can say is does not exist. Then finally, f of 1.5, that's going to be undefined. Because there is no y coordinate directly above or below x equal 1.5. Functional values are about what's happening exactly. And exactly 1.5, we have that asymptote. And our asymptotes are just really imaginary guidelines. That this particular asymptote is guiding one side nearly straight up and another side nearly straight down, but there aren't actual points on the asymptote. Okay, got the same graph on the next one. This time we're going to do 3 from the left, right, and two-sided. So again, in green. So I point to a spot close to 3, but on the left. And what I want to talk about here is a common mistake students do. For some reason, students always draw their vertical lines up. In my instructions, I said, point to a spot close to, in this case, 3, and then move vertically to touch the function. And so if I'm going to touch the function, remembering that this open and closed circle, those are directly above and below 3, and they're hugely magnified. So when I'm off to either the left or right, I'm not going to touch that open and closed circle. So off to the left, I'm not going to touch those circles. If I want to touch the function, I'm going to go down, then over, and it appears that my limit in this case is -3. There are some students that always go up. But notice, if I cover some stuff up here, if I go up here, well, it's not going to work like that. If I start at my green dot here and go up, I'm not going to touch anything. So remember that closed circle is directly above 3. So if I go up, I won't be touching anything. So it's not up here that you want to do. But on the right side, in pink, as x approaches 3 from the right, so now I'm going to put a point close to 3, but on the right, go and move vertically to my function. This time, I'm going to go up, because below, there's nothing. Up and over. And it looks like I am close to 2. And so my function, my limit as x approaches x approaches 3 from the right of f of x is going to be 2. And so then the two-sided has to be does not exist, because left does not equal right. Then finally, f of 3. Can I get it on there? Yeah. F of 3. Closed circles are honest-to-goodness points. They've been emphasized, but they're still just ordinary points. Open circles are a missing point. So when I want to go and find f of 3, I'm looking at that closed circle. And so f of 3 is going to be 2 from the closed circle at 3, 2. Open circles represent a missing point, or in this case, that the graph's coming right up to there but not including that point. Then it jumps up here, actually includes the point 3, 2, 3, 2, and goes on. So my functional value here is 3, 2 from the closed circle. Okay, let's do it again. New function, same function. This time, x approaches 4 from the left, as always, in green. So right there. Going to go up there and over. And this one's not going to look really great, and we'll talk about it more in a minute. So we'll do that. And then let's do the one in pink, the right side. Pink, same deal. Up and over. And it looks like they'd be distinctly different. But use your imagination that if we kept coming closer and closer, and if I do it again, another green line a little bit closer, maybe there'd be another green line that would look like right about there. And let's see if I can get another pink line in there. And maybe my pink line would be right about there. It's looking kind of messy, but maybe a pink line would be right about there. And if we use our imagination and think about those lines coming closer and closer and closer to exactly 4. Not quite 4, but getting closer and closer and closer to 4. So close you couldn't even get a hair between where we are and 4. If we envision that, we see that they both are coming close to a y-coordinate of 4. That they're going to come closer, closer, closer. They're not going to quite get there, but closer, 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 which makes the limit also 4. Because left, the two-sided limit, has to also be 4, because left and right both equal 4. But sometimes you have to use your imagination of what's going to happen as I get closer and closer and closer. Now the interesting thing to notice here, so there is a two-sided limit, because as I were to trace both sides coming closer and closer and closer, both sides, my fingers would come close to meeting, and they'd come close to meeting at the y-coordinate of 4. So you're going to have a two-sided limit when if you trace both sides, your fingers come close to meeting, and whatever the y-coordinate they are close to is your limit value. Now functional value here, undefined. Oh no, not undefined, excuse me. My functional value here is going to be -5. from this point here that I have a closed circle, 4, -5. Let's see if we can make that so it's readable. So f of 4 equals -5 from the closed circle. And that's where we will end this video.